let's talk about graphing quadratics. There's lots of different forms that you're going to see when you're graphing quadratics, but today I'm just going to go through what happens if you have pretty much your most basic type of quadratic. So that's going to be an x squared with a multiplier, and it's going to look like what I have here on the screen, y equals ax squared. So we've got that x squared, that quadratic piece, and then we have a coefficient of whatever a is. So let's talk about what would it look like if your leading coefficient was just 1. So there's no visible number in front of your x squared. How is that graph going to look? Well, anytime you're graphing, if you're stuck or you haven't learned it before, you can always just make a table, plug in some numbers, and then make your graph from there. So I'm going to plug in some x's and some y's. We'll make our table, and then I'll draw our coordinate plane and we'll sketch everything out. Usually we want to start with 0 and then do a couple numbers above and a couple numbers below 0. So I'll go 0, 1, and 2, and then -1 and -2. And all we do is we take these numbers and we throw them into x, we do the calculations, and then we fill out our table. So when x is -2, my y is going to be -2 squared, which is +4. So +4, and I'm just going to do this for all of the values in my table. And there's my table. So let me go ahead and erase all that work. I'm going to draw a coordinate plane, and then we're going to go ahead and throw all of these xy pairs onto the coordinate plane and explore the graph a little bit more. Okay, so now I just take the ordered pairs from that table and I throw them into the graph. So my first one is -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And when I connect them, it does kind of look like a V shape, but we're going to connect them in a smooth curve, and it actually creates more of a U-shaped graph. Let me try that again. Smooth curve, and there is my U-shaped graph. And we call this shape a parabola. So when you are graphing quadratics, the shape that you're always going to get is a parabola. So anytime you're graphing a quadratic, something with x squared, then you should have this smooth U-shaped graph. Okay, let's do a couple more. This one, we're going to change that coefficient to a 2, and we're going to see how that changes our graph. So again, we'll just create a table. We'll plug in some x's, and we'll figure out the y's. Put 0 in the middle, a couple numbers higher, and a couple numbers lower. And then I just throw each of those x's in and find each of the y's. Remember to always do exponents first. -2 squared gives me +4, and then I multiply by 2 to get 8. And I will do this for all of the numbers in my table. Okay, so there's my table. Let me go ahead and sketch the graph, and we will throw these into the coordinate plane. Just like the last one, I'm just going to go down the chart and plot each of these ordered pairs on the plane that I just drew. So -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. Connect them in that smooth U-shaped curve, and there's the graph of our parabola. It's a little bit hard to tell since I did hand sketch all of my coordinate planes, so things aren't exact. But if we pull up the last graph that we did, you'll notice that this one is a little bit wider than the one that we have now. And that's because in this one, we multiplied everything by 2. So we took all the old y values that we had on the last graph and we doubled them, but we kept the x values the same. So basically, we took the certain y point and we stretched it up by 2. So this is a vertical stretch of the last graph, and that comes from this coefficient of 2 that we have in the front. Okay, let's do one more. I'm going to take us through this one. So same thing, we'll still create a table, plug in the x's, and then calculate our y's. And there's my table. So again, let me erase everything and I'll sketch out a coordinate plane. My first point is -2, -2. So now we're going down below. -1, 1/2. I'm just going to kind of approximate there. 0, 0, 1, -1/2, and 2, -2. And here is the graph of my parabola. So now you notice in this one, the graph actually points down. In the last couple, they both pointed up. And that is because this graph has that negative in front of my 1/2. That negative causes our graph to reflect vertically. You might see it as a reflection over the x-axis or just a vertical reflection. So we went from up to down. That's what makes it a vertical reflection. Also, this graph is a little bit wider than the last few graphs that we had, and that's because we're multiplying everything by 1/2, and that's going to cause our y values to become half as large as they were. So if we have a certain height and we cut it in half, things kind of get squished down, and because we're squishing down the y values, everything will kind of widen out a little bit. So that's how we end up with this graph that we have. Couple points that I haven't talked about. The first is a very crucial point, and that is this kind of turnaround point in your parabola, and that's what we call the vertex. And like I said, that's essentially just the point where you turn around in your graph. It's either going to be the highest point. In this case, I have my vertex at the very, very top of my graph, or maybe in like one of our other ones from before, your vertex is your low point. So either way, it's the point where your graph hits a either maximum or minimum and then turns around. Another important characteristic of your parabolas are the axis of symmetry, and that's the line that cuts your parabola right down the middle. Because your graph is the same on the left and the right, we call this an axis of symmetry. And those are just a couple of pretty basic characteristics of parabolas that you're going to come across as you go through your math. There's lots of other things you can learn about parabolas, lots of other vocab associated with it, but this is just kind of a good general start for you. So hopefully that helped. Thanks so much for watching, and I'll see you next time. Bye.